Alright, welcome back. So now we are going to be dealing on this question at the left hand side of the board. Now it says a sample of oxygen gas has a mass of 5.00 gram and is contained in a flask with a capacity of 6.00 liters at 35 degrees Celsius. Assuming ideal gas behavior for the oxygen, calculate the pressure of the gas in millimeter of mercury. Atomic mass of oxygen is 16.0. Now remember, I told you your parameters that are given to you will tell you the formula to use on ideal gas. Now let's bring out our parameters here. Now a sample of oxygen gas has a mass of, now we're given the mass to be 5.00 gram, which is same as 5 gram, and is contained in a flask with a capacity of 6.00 liters. So our volume will be 6.00 liters at 35 degrees Celsius. Now our temperature is 35 degrees Celsius, so we can convert to Kelvin by adding 273 to it. Now they say assuming ideal gas behavior for the gas, which is oxygen, calculate the pressure. So our pressure here, is unknown. Now what should we do here? Now this is the atomic mass of the gas. Now let's take a look at these parameters we have here. Now we have mass, we have volume, we have temperature, we have pressure. Now there is no equation under gas law that talks about mass apart from the Graham's law of diffusion. Now if we look at this now, remember PV is equal to nRT. Now in this formula there is nothing like mass here, but remember that mole is equal to mass over molar mass. Now from here we can get our mole. How do we get this thing we have here? This is the mass, so we have the mass here. Now they're talking about oxygen, so we are dealing on the molar mass of oxygen. So we're giving the atomic mass of oxygen, then they say the molar mass. Now 1 mole of oxygen gas is 16 times 2, which is 32 gram per mole. Are you getting what I'm saying? So now if we are to find the mole here now, our mole will be, in order to put it in this equation here, our mole will be the mass. What is the mass? We have 5 gram over molar mass, and I told you molar mass of oxygen here. Sorry, the atomic mass of oxygen here is 16. So the molar mass should be 16 times 2. So now we have here, let's multiply the denominator, then 5 be divided by 8. So we have 15 divided by 32. So we have our number of mole to be 0.15625. Now this is our mole. So let's put it into this equation. We're looking for our pressure, so pressure is unknown. So we have P times the volume. What is the volume? 6.00 is equal to number of mole. Number of mole is here, which is number of mole is here, which is 0.15625 times our rate will be 0.0821 times our temperature. Temperature should be in Kelvin. So what do? This is 35. Then we add 273 to it. So what does it give us here? We have it to be 308 Kelvin. So we have 308 Kelvin. Now our pressure will divide it by 6.00. 6.00. So our pressure will give us. So our pressure should be 0.67 atm. Now, our parameters tells us, okay, this is what your units for pressure should be. Now we have here our volume was in liter. So obviously this should already tell you that our pressure must also be in atm. So that is how our answer became the pressure in atm and not in millimeter mercury or in any other unit. Alright, so now we have here, it said calculate the pressure of the gas in millimeter mercury. Okay, so now remember I said 1 atm. Remember on our last video or our last class, I said that 1 atm is equal to 760 millimeter mercury. So now they are not asking how many of this atm will be in millimeter mercury. So now let's look at this relation here. Let's do some relation here. Remember I said 1 atm gives us 760 millimeter of mercury. Now they're not asking how many of that atm will give us millimeter mercury, which is 0.67. Will give us how many, which is unknown. Now 1 atm gave us this, so how many of this will give us this is unknown. So let's cross multiply here. We have 1 times s will give us x. X will be equal to this times this. So we are crossing it like this. So this top here multiplying this down, and this top multiplying this up here. So this is multiplying this. X times 1 give us x. Then 0.67 times 760. So we have this to be approximately 509 millimeter of mercury. Now this should be the answer to this question. All right, thank you.